Welcome to solverfy.
So first, we want x to be the distance from B to C. So the distance from the island to C is going to be the square root of x squared plus 25, because 5 squared is 25. And then the distance from C to D, or we'll write it like this, C to D is going to be 13 minus x. So the total distance traveled will be the square root of x squared plus 25 plus 13 minus x. So if k is the energy per kilometer it takes to fly over the land, then our total energy, which will be modeled by the function e of x, is going to be 1.4 k times x squared plus 25 plus k times 13 minus x. Then we find e prime of x, and keep in mind that k is a constant, and what we end up getting as a result is k times 1.4x minus square root of x squared minus 25 over the square root of x squared plus 25. So it's plus 25 in both cases. And then we want to set that derivative to equal 0. Now, we always remember that the bottom doesn't really matter. We're more focused on the top, because when the top equals 0, the numerator is equal 0, the whole fraction equals 0. So we have, since this constant could just be divided out, what we really have is 1.4x minus the square root of x squared plus 25. We solve for x, and we end up getting that x is equal to plus or minus the square root of 25 over 1.96, but in or 0.96 actually. But in actuality, since it's obviously just going to be the plus answer, what we have is 5.1 kilometers. Then we see that e prime of 1 gives us a negative 0.7 k, so that's obviously less than 0. And then e prime of 10, so we're picking a point above and below this 5.1. We see that this one right here is 0.25 k, which is greater than 0. So what we have is we are decreasing in slope, and then we reach this 5.1 kilometers, and then we're increasing in slope. So what that tells us is that 5.1, this is a minimum. Then we have our next part, part B. So we know that if W over L is large, then the bird would fly to a point C that is closer to B than to D in order to minimize the energy used flying over the water. However, if it's small, then the bird would fly to point C that is closer to D than to B in order to minimize the distance of the flight. So what we have is that E equals W times x squared plus 25 plus L times 13 minus x. Then E prime of x is going to give us x W of x over square root of x squared plus 25 minus L of x. When we isolate, we set this equal to 0. And when we isolate W over L, we end up getting that this is x squared plus 25 over x. So the above ratio will minimize the energy if the bird aims for the point that is x kilometers away from B. For part C, going directly to D means that x will equal 13. So W over L is going to equal the square root of 13 squared, which is 169, plus 25 over 13, and that's going to give us 1.07. So there is no value of W over L for which the bird should go directly to B. And then our last problem, D. If the birds choose a path that minimizes energy, that's going to be dE dx which equals 1.4 kx over root 25 plus x squared minus k. We set that equal to 0, and what we end up finding is that 1.4 kx equals k times x, the square root of x squared plus 25. K's cancel, we solve for x. We get that 1.4k, if we let this equal c, and then x equal 4 and k equal 1, we get that c is approximately 1.6.